Hola, mi clase. So we are doing 7.5. It's called Factoring Quadratics. So our essential question, or I can factor quadratics. So we're still just factoring. A quadratic is just a specific type of graph, which we will actually do in, I believe it's topic 8. So, but we're just factoring. So just keep in mind, I know the word quadratic is kind of new, but we're just factoring. So remember, factoring is finding what two multiply together to get an expression. It's distributive property backwards or inverse of distributive property. So it says, how does factoring a trinomial, 1, 2, 3, relate to multiplying a binomials? Remember, binomial means 2 and trinomial means 3. So we're going to multiply these binomials and see how they relate to this trinomial. So I'm going to first multiply my binomial. So x times x gets me x squared, and x times 3 gets me 3x, and then x times, oh, not that one, I'm done with that one. Whoops, hold tight. 2 times x gets me 2x, and then 2 times 3 gets me 6. So remember, we wrote these out as like x plus p and x plus q. We use kind of these different variables. So we're kind of trying to see, like, how does this relate to this? Or how does this relate to this? And if we notice that if we take p and times it by q, we get this last term. And if we take p and technically add it to q, right, 3 plus 2, you'll notice I get that middle term. So just like when we were doing special special multiplication, and I could just take those terms and multiply them and things like that, we can do the same thing when it comes to factoring, so that we can see there's a relationship here and here. And so if we notice, the last term is the product of my binomials, and then the middle term is the sum of my binomials. Okay, and so we're going to see how that can be used to then factor a little quicker and easier. Okay, so remember this, multiplying them gets me my terms, and adding them gets me my last term, and then adding them is going to get me my middle term. So down below is factoring a quadratic rule. So we have x squared plus bx, this middle term is called b, plus c, the last term is called c, and notice I put the terms x plus q and x plus, p and then q. So I told you this, that p times q is going to get me, now we call it c, and then p plus that q is going to get me, and we're going to call it letter b. But this is our last term and our middle term. This is our quadratic. Okay, this is the form of a quadratic, a x squared plus bx plus c. Okay, so what we're looking for is we want to find what multiplies to get 36, but then adds to get 13. So it's kind of like listing my factors. I always start with listing my factors of 36. So like, I know I need to add to 13, so obviously I'm not going to do 36 in one, but like I can do 12 times 3 gets me 36, but 12 plus 3 does not equal 13, right? It equals 15, so that doesn't help me out. So then I would do, maybe 9 times, what is that, 4? Well, that gets me 36. If I do 9 plus 4, that actually does equal 13. And so now that I've found my set that equals adding to 13 and multiplying to 36, I can then use that to factor them. So I know that multiplying them gets me c and adding them gets me b. Okay, so I can then go x plus 9, x plus 4. Okay, I know they're both positive because These are both positive, okay? And so that's how I can use this situation to quickly factor this, okay? It's not just pulling out like we did last time, right? Just finding a common term. I don't have anything in common, so then we would factor slightly different. Okay, so what I would like you to do is see if you can find what's going to multiply to 28 but add to 11, okay? Multiply to 28 but add to 11. All right, so the factors of 28 are 7 and 4. And if I take 7 plus 4, it's in fact going to get me 11. So then my factor is x plus 7 and x plus 4, and I'm done. Okay? And it's easy, that easy. And it's all positive because these are all positive. So it says, what is the factored form of x squared minus 11x plus 18? So this is where it gets a little tricky because this is positive, but this is negative. So we have to then remember that a positive multiplication could in fact be two negatives. So for example, negative 9 times negative 2 is also positive 18, just like 9 times 2 is. The difference is 9 plus 2 is positive 11, but we want a negative 11, so this does not actually work for us. But negative 9 plus negative 2 does get me what I want, which is negative 11. So when we start getting factors that are negative, our products are negative or positive like this, when they're matching, or I mean opposites like this, then we need to remember that we can have factors of negatives. A negative times a negative will get me a positive. And so we have to keep in effect and keep in mind that we can have things as negatives, okay? So just like 9 times 2 gets me 18, but 9 plus 2 does not get me negative 11. So that's where these negatives need to come in, is that negative 9 times negative 2 will get me 18, and negative 9 plus negative 2 does get me what I want, which is negative 11. So then our factoring would be x minus 9 because it's negative, and x minus 2 because it's negative. And that would be our factor. Okay, so for this one, I actually first can pull out an x. Do you notice how they all have an x in common? So that's the first thing I'm going to do, is I'm going to factor out that x. So I'm going to get x squared plus 2x minus 48. So that's the first thing I'm going to do. So then we need to see, can I factor out anything else in this quadratic? Meaning, can I take this and break it down more? So now I'm looking for negative 48 product and positive 2 sum. So I know that, 12 times negative 4 gets me negative 48, but 12 plus negative 4 does not equal 2. Okay, so that doesn't work. I could always switch it. Negative 12 times positive 4 is negative 48, but still doesn't work. Negative 12 plus 4 is not 2. I can do, what would that be? Trying to think of factors. I'm really blanking right now. 6 times negative 8 gets me negative 48. But 6 plus negative 8 is not 2. What if I switched it? Negative 6 times 8 equals negative 48. And negative 6 plus 8 is in fact 2. This is the one I want. Whoops. I got a little crazy with my circle, but there's the one I want. So what we're going to do is we're going to leave this x out here, and then I'm going to write 6 or x minus 6 times x plus 8. And this is our fully factored trinomial, right? 1, 2, 3. So I first took out that x because they all had an x in common, and then I factored this down to two sets of binomials. So there's my fully factored, that's what they mean by completely factoring our trinomials, okay? So now we can sometimes take out our x like we did in our 7-4, and then we need to factor out this quadratic into two binomials. Okay, and you can see here I have those opposites again, but this time instead of having both negative like I did here, I may need to have just one of them negative, and sometimes you need to switch them to get what you need in the middle. Okay, when I had -8, it didn't work, it was -2. Should have crossed that off. But when I had +8 and -6, it worked, and it was +2. Okay, so you may need to sometimes switch them. All right, so this is how does multiplying binomials in two variables relate to factoring a trinomial. So it said consider the following binomial products. So factoring this with two variables is actually no different than factoring it if it was not double variables. If we notice, it's just x, y in the middle, y squared, x squared. So we almost just kind of ignore those again. I'm still looking for what multiplies to this and adds to this. So I'll show you. So what if I multiply here, there's my x squared. And if I multiply here, I get plus 4xy. If I multiply here, I get plus 2xy. And I multiply here, I get plus 8y squared. 4 times 2 is 8, and y times y is y squared. So you'll see, look, product. So 2 times 4 is 8, and 4 plus 2 is 6. And look, there's my 6, and there's my 8. So you'll notice it's exactly the same. We just kind of ignore the variables. It's no different than what we just did, except for the extra variables, but it's still product of P and Q and sum of P and Q get me my last term, which we now call C, and my middle term, and that's supposed to be a C, I'll fix it, which we call B. It looks more like a G. It's bothering me. So, same idea, right? Looks exactly what we just did. So I'm only looking for what multiplies to get 24 and adds to get 10. So 6 times 4 is 24, and 6 plus 4 is 10. The only difference, again, is that I add my variables. So it's going to be x plus 6y and x plus 4y. Okay, just to prove to you, I'm going to distribute. So if I multiply the first two terms, it's x squared. If I multiplied, maybe I should do them in the order I always do them. The last two terms like this, I get plus 4xy. If I do these two terms, I get 6xy. And if I do these two terms, I get 24y squared. And look at the middle, I add those together, and I get 10xy. So it's just like what we were doing, except we now have two variables. The first one has x, and the second one has y. So it says a parallelogram has an area of x squared plus 9x minus 3x. What are expressions for the length and the width of the parallelogram? So just like we did in 7-4, we're just going to factor this like we've been factoring, and one will be our length and one will be our width. So I'm looking for -36, but adds to 9. Okay, so if I do -12 plus 4, nope, 3, I mean times 3, that gets me -36. But if I do negative 12 plus 3, that doesn't get me positive 9, it gets me negative 9. So what if I switch them? What if I do 12 times negative 3 equals negative 36? And if I do 12 plus negative 3, I do in fact get positive 9. All right, sorry, I had to help Mr. Barrow. So now that we have negative 36 and positive 9, we know that the width and the length are x plus 12 and x minus 3. So it says if x is an integer, what is the least possible value of x for a parallelogram to exist? So meaning, what is the smallest number we can plug in that will make this thing actually be real? And the reason we say that is because sometimes when I plug in numbers, they don't actually exist, right? Like we saw that on one of, I think it was the warm-up of like, what can I plug in? You know, are these measurements actually real? And it ended up not even being real, okay? So here's what I'm gonna do. I'm actually gonna leave this. I wanna see if you guys can kind of guess and check, and we'll kind of talk about it in class next time. I think it'd be important to have the discussion together about what are the possibilities for x to be a real number. All right, so things to remember is just remember when we've got that x plus p and x plus q, when we multiply it, it's going to get x squared plus bx plus c, and p times q will get me c, and p plus q is going to get me b, okay? All right, so here's your independent practice. You got 2 problems to factor. Don't forget these negatives. They're super, super important, okay? All right, until next time, adios.